Welcome to 7.2 Law of Sines, where we're looking at the ambiguous cases of the SSA triangle. Example 3, solve triangle ABC given B equals 68.7 degrees, side B equals 25.4 inches, and side A equals 19.6 inches. So because we are given two sides and the angle that's not included in between the two, this is going to again be an SSA. So we have to look out for 0, 1, or 2 triangles. Let's start by finding sine of A. Using the law of sines, we have sine of A over A equals sine of B over B. Plugging in the numbers, we get sine of A over 19.6 equals sine of 68.7 over 25.4. Solving for sine of A, either by cross multiplying or by multiplying both sides by 19.6. Therefore, we get sine of A equals 19.6 sine 68.7, all divided by 25.4. Putting this right-hand side into our calculator gives us approximately 0.7189. Since this is in between -1 and 1, we know we'll get at least one solution. So to find that angle, we'll find sine inverse of 0.7189, keeping that number in the calculator. Therefore, our original A value is approximately 46 degrees. Now, because this is an SSA, we need to see if another triangle exists. Once we calculate this initial angle, we have to ask, is there a second triangle? So we find out by calculating the third angle. So remember, we found A1 to be 46 degrees, but sine could be positive in quadrants 1 or 2. So this is also 46 degrees. So this angle in quadrant 2 might be a second angle A that would work. And we find that by doing 180 minus 46, or we get 138 degrees. So we don't know if this works yet. To determine if a second triangle exists with this given information, we need to calculate the third angle of this triangle. So C2 is going to be 180 minus B minus A2. So we're just trying to see if it's possible for this triangle to even exist. So in order to check to see if this second triangle exists, we have to see if this 138 degrees could work. We need to calculate this third missing angle for this obtuse triangle. So we could do 180 minus the 68.7 and minus the 138. When we do this calculation, we find C2 to be negative 26 degrees. Well, that doesn't make any sense. So as soon as we get this negative, we know that there is no second triangle, because we cannot have a negative angle in our triangle. So now we know we will only have one triangle with the given information, and we have found that angle A is 46 degrees. So now we need to find angle C and side C. Since we already know two angles of the triangle, we can easily find angle C. So C is 180 minus 46 minus 68.7, or we get angle C is 65.3 degrees. Now we're ready to find little c. We need the law of sines for that. So since I'm looking for little c, I will put little c up top, so I'll need sine of angle C on the bottom. And since I was given both B and angle B, I'll keep B over sine B on the right. Plugging the numbers in, we get C over sine of 65.3 equals 25.4 over sine of 68.7. Either multiplying both or cross multiplying, we get C equals 24.8, and our units are inches. So looking at our results, we see that the smallest angle is opposite the smallest side. The largest angle is opposite the largest side. And you might also notice that angles B and C are pretty close to each other, which resulted in sides B and C being rather close together. To sum this up, because we had an SSA triangle, meaning that we were given two sides and an angle that was not the angle between them. Once we find this first angle, we have to see if there's a corresponding angle in quadrant 2 that might work. And the way we can see that is first we calculate that angle, and then we go ahead and try and find the third angle in this new triangle. And if that third angle gives us a positive, like it did in example 2, then we know we get that second triangle. But if we get a negative, which most of the time we will, if we get a negative, then we will bag this second triangle and just worry about the first triangle. And make sure to solve that first triangle in its entirety. Okay, let's take a look at example 4. Without using the law of sines, explain why B equals 93 degrees, side B equals 42 meters, and side C equals 48 meters cannot be valid for a triangle ABC. So this is a great time to pause and try and figure out why this cannot be a triangle. I will go ahead and draw a picture. There are a lot of ways to describe this, but one way to establish that this is impossible is because 48 is bigger than 42, that means that angle C must be bigger than angle B. However, if we take something that's bigger than 93 degrees and add it with another 93 degrees, we are going to get more than 180 degrees. And that is impossible because A plus B plus C, all three angles must add up to be 180 degrees. So B must be the largest angle because it is obtuse or more than 90 degrees. So it should be opposite the largest side. But B is actually less than C, which is not allowed. If we were to apply the law of sines, we would get sine of C is approximately equal to 1.14. And we know that sine values must be between -1 and 1. So you can also see that the law of sines shows us that this triangle is not possible. I hope you enjoyed this video. See you next time.